arc length and area of a sector. This is good. So if I have a circle, and I'm using this right here. Suppose I have an arc that's 60 degrees. So that's one way to talk about arcs, their measure. So that would be like if this was AB. Okay, that would be the measure of arc AB. They put that M in there, meaning find the degree measure. Okay, that would be 60 degrees. But they could also say find the length of an arc, or just arc length. And what that's going to be is, first of all, the concept is just a length. Like perimeter is a length around the circle. Arc length is also a length. And since an arc is just part of a circle, arc length is simply part of the circumference. So I say here, the measure of an arc is in degrees. That's what this was, 60 degrees. While the arc length is a fraction of a circle's circumference. So on this one, if I was finding the arc length, the length of this arc here, I would do 60 over 360 represents how much of the arc it takes up from the whole circle. That would be 1/6, and so the circumference would be simply 1/6. I'm sorry, the arc length would be 1/6 of the circumference. So you're doing circumference, just doing a fraction of it, just part of it. Okay. So let's write it more in a formula. This is the one that's on the formula sheet. Circumference is 2 pi r. Now, these are not on the formula sheet. So we have two boxes today. The right theorem formula is not on the formula sheet. So arc length is going to be, this is just going to be a fraction of the circumference. Now, what fraction do I need? Well, I need whatever part of 360 out of 360 it was. So this one was 60 out of 360. So basically, overall, we're going to get the measure of an arc divided by 360. So this is the fraction. Let's put part or fraction. And this is circumference. So we're just getting whatever part we want of the circumference. Okay, that is not on the formula sheet, but all you need to know is to do a fraction of this one. So let me do an example, and we'll see if there's any questions. So we're doing the length of arc xy. And we're going to leave our answer in terms of pi. So here's xy. It's a minor arc. First of all, I need the measure of the arc for xy. And so I'm given that this red arc is 240. The whole circle is 360. And so I can subtract the 240. And we'll get 120. So we get 120 for the measure of the arc. So right here, this is, by the way, this is not m times parentheses. This is just measure of an arc, just a number. Divided by 360, so that's the part of the circle we want, the fraction, times 2 pi, and then the radius is 15. Okay. Now at this point, I'm just going to put this in my calculator. I'm leaving out the pi. So I'll show, and by the way, a lot of calculator we'll need today. So please have a calculator out. You can try these. I'll show you what I'm going to do. I'm just going to do 120 divided by 360 times 2 times 60. Really might do the fraction up there. Probably better if I did the fraction. Okay, so 120, 360 times 2 times 15. Okay, so you get 10, and then you left the pi out, so we'll put, so there it is, 10 pi. And this is still a length, so I'll keep it as centimeters. That should really be closer, 10 pi. There we go. By the way, if you wanted, sometimes I see students reduce this first to like 1/3, and they reduce 2 times 15 is 30. And so they get 1/3 of 30 pi. And that's fine if you want to do that. You could also just put it all in at once. Okay, sometimes it'll also say round to the nearest something, and you could put this in your calculator, but no need on this one. What can I answer about arc length? No questions on this one? Alright, well, number one, area of a sector. What you're going to notice, it's almost identical to this. There's only one very slight change. First, I need to tell you what a sector is. So a sector, this is the technical definition. Let me just talk about it. Let's look at one down here. A sector, you got a circle, I just imagine like a slice of pie, right, from the whole. It's that yellow region, or like a piece of pizza. So it's just that region. Now, technical definition over there, it's an arc, and then you have two radii. It's the region formed by two radii in an arc. Okay. Now, a good question will sometimes come up. How do you know if, so they say sector GPH. How do you know if it's the little sector or if it's actually this big sector? That's a good question. There's not a great classification for that. So it's just going to be by like shading. Like they'll shade this or color it or something, and that's how you know which one to do. All right. So that's what a sector is. So we're going to find an area of a sector. And it's very similar as before, the other formula, but it's going to be pi r squared instead of 2 pi r. So the area of the full circle, pi r squared, but we only want a fraction of it, and it's going to be the exact same as before. The fraction part is just a measure of an arc over 360. That gets the part we want. Times the full circle. So this is pi r squared, the area of the full circle. So the only change from the first one is instead of 2 pi r, it's pi r squared. Okay, so let me show you on this one. So we're finding this area. And let's say I'm just going to use that formula. Now we already have the arc degree. It's 72. Divided by 360. And then times pi 15 squared. And it does say leave your answer in terms of pi. So again, I'm really just entering 72 divided by 360 times 15 squared. Somebody want to help me out? What'd you get for that? 45. And again, you could reduce. This would be 1/5. 15 squared is 225. You don't have to show that work though. It's nice to have just a setup step here and then that answer. Oh, and notice I put squared centimeters because this is area, so it's squared units. Okay, so that's the basics of arc length and sector area, and I'm going to just two other examples, slightly different from what we've done, but still very similar. So how about any thoughts on sector area? And again, this formula is not on the formula sheet. They give you area of a circle. You just have to remember to do this. Bless you. Okay. Let's look at example 3. Now, I really like this one. What they do here, they tell us to work backwards. They give us the area of a sector, 12 pi squared units. There aren't any units. So they give us the area of a sector, and they're going to ask us to find, these questions will ask you to find either, so they give you this, you have to find either the measure of the arc or the radius. And so it's just working backwards, and you're going to have to solve an equation. I chose area of a sector. They just as easily could have given you arc length and asked you to find radius or measure the arc. Right, so it's just working backwards. So usually radius is plus, but sometimes the measure of the arc. Okay, so I'm going to write down the formula. I'm going to put just A sub S being area of a sector. You could write out area or just A or whatever you want. What is it? Measure the arc over 360 times pi r squared. Okay, then I'm going to just fill in what I know. I know that the area of the sector is 12 pi. Put that in here. Let's see, the measure of the arc that we want, that we're interested in, so like this one is 80 degrees over 360, and then find the radius. So I'll have to leave it as times pi r squared. Now it's just an equation. So if you like solving equations from here, you're going to enjoy this. So we need r. First thing, there's going to be different ways to solve this, by the way. Here's what I'm going to do. First thing I'm going to do is cancel out pi. I can do this because everything over here is multiplied together. So really, I'm technically dividing both sides by pi. All right, so if there was a plus or minus somewhere in there, I wouldn't be able to just divide right away. But I can cancel out pi there. So I'll be left with 12, and then 80 over 360 times r squared. What would you want to do next? Clear the denominator. Clear the denominator. Now, I'll do that. I do want to show you there's another way you could do this as well, though. We're solving for r. So clearing the denominator, multiplying by 360. Somebody help me out. Is this right?
Yes.
4320. 80 r squared. And then we're solving for r squared, so you're going to divide by 80. Yeah. So here's the thing I wanted to say. I will divide by 80 here. But you could have done this all at once. So if you wanted, you could have in the last step, I don't know if your teacher did this, like if there was a fraction, you always multiplied by the reciprocal. So like if it was 2/3 x equals 5 or something, then you multiply both sides by 3/2 to get rid of these at the same time. You can do it in 2 steps if you wanted. So same here, we could do it in 2 steps, or you could do it in 1 step by multiplying by 360 over 80 and canceling them at the same time. But you don't have to. Just showing you an option. We did them separately. So this is 4, and this is r squared. Okay, and then we do a square root to get rid of the squared, and so now I left mine as square root of 54. I didn't tell us what to round to here, so if I don't tell you, you have the option. You could leave it like this. You could write it as, what would that be, 7 point something. That's an r, by the way. All right, so working backwards, solving that equation. Yeah, cancel the pi, multiply, clear the denominator, and then divide it, then the square root. Anything on the answer on number 3? No. Let's do one more. I think this is a nice one. It really just brings everything together here that we've been doing for the past 2 sections. Okay, so last one. What is the area of the shaded region in the diagram? We'll round to the nearest 10. Okay, so really in the shaded region, it's everything except this little sliver up here. All right, that's the shaded part that we need. So what I'm going to do, there's probably another way to do this, but this is probably the most efficient way. We see a triangle, right? Right there? And then actually, do you see the big sector? It's like a Pac-Man type sector. Like that. I'm just going to do each one separately, because we just found out how to do area of a sector, and then we know area of a triangle. So I'm just going to break it up that way and do them separately. So let's do the sector in red. So it's the big sector. Let's see. So it's going to be the measure of the arc over 360. So here's where we're bringing stuff from last section, where the central angle is 60. Therefore, the arc that goes with it is also 60. And then we can subtract from the whole circle, being 360. And find that the red arc would be 300, the big red arc. Okay, what else? So then we need times pi r squared, and r is 8. do this one. So 300 divided by 360, and then times 8 squared, so it'd be 64. So that's fine. Your calculator might say a fraction. You could do decimal. It doesn't matter. Doesn't matter. So I'll do what it did here. 53.3 repeating pi. Don't forget the pi on that. Your calculator might know the fact like 160. Is that what it is? 160 over 3. Alright, let's go on to the triangle. So area of a triangle, 1/2 base times height. I think we know that one. It is also on the formula sheet. Okay, what I'm going to do, I'm going to flip the triangle over so we can see a little bit better. And okay, another thing is this is these are both radii, so this is also 8. Thank you. Both radii, so they're both 8. Okay, I can draw on any radius I want, and that's 60. All right, so I'm going to flip it upside down so we can see it a little bit better. Now, if these are both radii and they're both the same, they're both 8. Now the triangle is isosceles. The isosceles triangle theorem says these angles are congruent. If I've already used 60, I would have 120 left for the triangle. Let's start with 180. So subtracting 60, we got 120. And finally, dividing by 2, since these are both the same, we get 60. So it ends up actually being equilateral. And so it can start as isosceles, which it is, but it ended up being equilateral. All right, so what does that mean? That means that the base that I'm going to use of this triangle is 8. Okay, so I'm using this as the base, the bottom there, 8. Then I need the height. Here's the most common error I see on this type of question, and you can probably guess, students will put 8 as the height. Okay, but that's just a slanted, it's a side of the triangle, but it's not the height. Because height, we know, really means altitude. So if I draw in the altitude from the opposite vertex, altitude makes 90, and this is the height that we'll need. So if altitude makes 90 and this is 60, then this angle is 30. And so you should be thinking back to right triangles. The way that we're going to get the height is 30, 60, 90. Or you can do Pythagorean theorem. So again, it was isosceles, became equilateral, so this is 8. But I need to draw in an altitude, and I'm going to find the height. Okay, here's the diagram from the formula sheet for 30, 60, 90. 30, 60. So 8 is the 2x, the hypotenuse of the right triangle. And so the bottom is the x, and that's half, and so that'll be 4. You also could have just cut that 8 in half, knowing this was, since it's equilateral, it's bisected. So here's where, if you wanted, you could do Pythagorean theorem with the 4 and the 8. But since we know 30, 60, 90, we're just going to say it's 4 radical 3. Okay. So that one, it does take a little thinking there just to map it all out. Isosceles became equilateral, had to draw in the height and do some right triangle stuff to figure it out. Okay, so finally here, let's multiply these. Half times 8 is 4, and 4 times 4 is 16 radical of 3. I'm just going to leave it as a radical for now. All right, so finally, the area of the shaded region is just adding these together. So I'll just write down 53.3 pi plus the 16 radical 3. It did say to round to the nearest 10. So I'm going to put in my calculator. I have the 53.3 repeating. I'm going to times it by pi, so now it's that first one, 53.3 pi. And I'm going to add in the 16 radical 3. So to the nearest 10th, 195.3. I'm going to put about equal to, because I rounded. And I don't think there were units, were there? No. It's area though, so let's put u squared, unit squared. Last thing I'll say, earlier I had somebody say, I got 195.1. She's like, what happened? Why did you get? Well, that's the calculator. She put 53.3. She stopped it there. She didn't put the dot and continue the threes. So you'll notice you get a little bit off. Don't round that too early. So, okay. Add them together. That's the shaded region area right here. What can I answer on that? Anything about this sector? Triangle one? Yeah. Can I check it in a minute? Yeah, so that's a good question. If you weren't getting it, you should try it. If you weren't getting it, then I'll help you out.
Angles are